Well, I would very much, I'm very happy to introduce Rashelle Matthieson from Iowa State University. Rashelle works with Allison Robertson's team. And Rashelle has a bachelor's of science from Iowa State. She also has her PhD from Iowa State, and she's now a research associate at Iowa State. And so she's Iowa through and through. And so we're really looking forward to hearing about your research. And so take it away, Rashelle.
Okay, thanks, Jen. Actually, I defend for my PhD next week, so fingers crossed.
Hey, that's awesome. Congratulations. I thought that you were done, but we're excited for you.
Thanks. Okay, so thanks everyone for joining today. And I'm going to talk about the effect of rye termination timing on seedling disease, stalk rot, and yield of corn. So I'm just going to go through what I'm going to talk about this morning. And so I'm going to give a little bit of an overview of CE2, what we do, and then go into what the treatments are for the disease aspect of this project, and then the data collection of what we did, and then go over the results for seedling disease, stalk rot, yield, and then talk about some relationships that we would like to look at in the future with all of the data that we've collected and will be collecting. So for Common Experiment 2, we're across 16 states and 17 locations. There's 2 locations in Virginia. And like Jen said, so Dr. Allison Robertson and I are working on the disease aspect at Iowa State. Dr. John Tooker, and it was Matt, and now it's Jared at Penn State, and they are with the insect aspect of the project. And in Florida, it's Dr. Carlene Chase, and it used to be Param, and now it's Daniel from the University of Florida. So for Common Experiment 2, the main goal is to understand the effect of termination timing, weeds, diseases, slugs, insect pests, and corn growth and development. And so for Dr. Robertson and I, looking at the disease aspect, one of the reasons we started on this path is a couple of years ago, we were talking to farmers in Iowa who were planting cover crops, and they noticed that when they were planting cover crops a little bit closer to, or sorry, when they were terminating their cover crops a little bit closer to planting corn, they were seeing some lower yields and more seedling disease. And so we were interested in what could be causing that. And so we did some work, and we found out that so rye could act as a green bridge for different seedling diseases, especially like Pythium, and that can increase, the risk of an development of seedling disease, which ultimately can reduce, crop emergence and vigor, and then possibly lead to lowering yields. So in this nice little picture or slide that I got from Allison, we have our green bridge here. And what we're trying to say is that you can have, pathogens that colonize on the rye, and therefore, if the rye is not terminated a decent amount of time ahead of planting, then you could have your pathogen populations increasing. And so therefore, when planting does occur, those pathogens like Pythium species can transfer or infect the corn, and to a larger extent than if it was a greater amount of time between spraying or termination and planting. And so what I'm showing with these couple pictures over here or on the right is like the lower picture, there's mesocaudal rot, there's a little bit of rot on the radicle. And so this seedling would more than likely die. And what we commonly see, though, more in our fields in Iowa anyways, is that this picture on the top where you have a stunted seedling. And so you have some, rot that can occur on the mesocaudal and roots, but it stunts the plant. And so therefore then that plant is lacks nutrient ability or nutrient uptake, and therefore then its development is delayed. And so sometimes these plants do not produce ears, or if they do produce ears, they're, very small. And so that can then impact yields in that way also. So when we were working on this, that's why we thought that that would be an interesting aspect to add to this project. So for Common Experiment 2, the treatments for all the locations, the 17 locations, was we asked everyone to plant cereal rye and corn and then terminate with glyphosate. The plots are 16 rows wide, so 30-inch rows wide, and 50 feet long. So it's approximately 40 feet wide by 50 feet long. And we had 3 treatments. And so, of course, in Common Experiment 2, we're working with diseases, weeds, and insects. And so these are the treatments that were for all of the aspects of the project. And so we had a no cover crop or bare soil treatment. We had a planting brown treatment where the cover crop was terminated 2 to 4 weeks before planting. We had a planting green treatment where the cover crop was terminated 3 to 7 days after planting. And then one of the reasons I separated this bottom treatment here from the rest is these top 3 were mandatory, or we asked everybody to include these 3 treatments, but this 4th treatment down here was optional, and we included the planting green brown treatment as a way to have something in between these planting brown and planting green, mainly for the disease. So with planting brown, we had theorized we probably wouldn't get any disease, and planting green, we might get, some disease. So we didn't want an all or nothing. We wanted kind of to ask if anybody could plant this in between treatment where the cover crop was terminated 3 to 7 days before planting. And so we did have, it was optional. And so we did ask, and there were several states that were able to incorporate that treatment into with their rest of their plots. And so I just added a plot map here to show this is what the plot map was for Iowa and for the different treatments. And it was a randomized complete block design. And depending on the location, we did ask that everyone have at least like 4 to 5 replicates. And so some states had 3 treatments with 4 reps, or 3 treatments with 5 reps, or 4 treatments with 5 reps. So it did vary in that aspect, but we did ask that everybody plant these first 3. So for the plot map, or for the plot itself, I thought I'd show kind of a schematic of where we took sampling from. And so it's like I mentioned, it's 16 row wide plot, and the first 4 rows were for the weeds, and then 7 through 10 were for the insect, and for rows 5 and 12 is where we did the disease subsampling from, or destructive sampling. And we did seedling disease for digging seedlings in these 2 rows, and also stalk rot assessments where we split the plot, or split the stalk. And then we took yield from rows 7 through 10, and also did different assessments for like crop stand or crop emergence and barren ears and that sort of thing from those rows. Okay, so for seedling disease, we asked everybody to collect seedlings between the growth stages V3 and V5. And that is mainly because when the younger the seedlings, the better chance of seeing seedling disease. And so once they get to like V6 or older, we don't see a significant amount of seedling disease. So that would impact the plant. So that's why we asked, V3 to V5. We asked everyone to collect 10 seedlings. So dig up the entire seedling, including all the roots. And so that's 5 seedlings from rows 5 and 5 seedlings from row 12. And then take the seedlings back to their lab and just gently like soak them and gently wash them so we can get clean roots. And then we have like a picture here in the lower right of a tripod that we made to give an example for everyone to use to take pictures, and then to use a background, a lighter background, so we have some contrast between the roots and the background. And then so everyone took pictures and labeled their seedlings and their plot with the plot number. and seedlings 1 through 5. And then those photos were uploaded to the Google Drive, where then I accessed them and I assessed them for root rot severity. And in total, there was approximately 3,100 photos based on how many treatments and reps for each location that there was. So quite a bit of photos, but it was interesting to see all the different states. So for seedling disease, for overall across all locations, there was some variability with how much seedling disease there was, anywhere from 2 or 3% all the way up to almost 40% in the green treatment, which again was planting green. So that's 3 to 7 days after planting when the cover crop was terminated. And I'll probably keep repeating those a lot. We kind of use different things to, sometimes we call it brown and sometimes we call it early. So I'll really try to be consistent and describe each one when I mention them. So this is the first 8 states. And what we can see, right away is Iowa had almost 35% root rot in the after planting treatment, or the green treatment, where the cover crop was terminated 3 to 7 days after planting. And then, around 20% in the other 3 treatments. And what we saw too across a lot of the states is, so for Kentucky and Nebraska, we saw no significant difference. For some of the states, it was similar to Iowa, where you have after planting treatment here in Florida was significantly different from the other 3, or something similar to Delaware, where there was no significant difference between, say, 2 of the treatments, but that the planting green did have the most root rot. In the other 8 states, we're seeing that there's no significant difference for New York, but there we have Texas that's up to almost 40% in the green treatment when termination occurred after planting. So there was variability across the states, obviously, but the other thing I want to mention is that for the other 8 states and for these, so the old 16 states, except for Iowa and Texas, the majority of states had under 15% root rot, with some states, like Vermont having, 5 or under. So it was variable in that sense also. And I don't know what's going on with Iowa or Texas soils, but or it could be, down to environment, that's why we're seeing, differences. Obviously across the states, there would be different environmental conditions, but yes, we were interested to see why Texas would have more root rot also, as did Iowa. So just kind of an overall summary of that, there was 9 of the 16 locations had more disease or more severe disease in the green treatment versus the no cover crop treatment. And there were 11 of the 16 locations where there was more disease in the green versus the brown. And so again, the green is terminating 3 to 7 days after planting, and the brown is terminating 2 to 4 weeks before planting. And so I added these photos. These are some of the photos that were uploaded to the Google Drive, and from Texas and Iowa. And you can see that, there's some mesocaudal rot here. There's rot on the radicals and other roots. So that can then impact, a growth and development of these seedlings. So something like this, I would expect, this seedling from Texas to possibly die or for surely be stunted as growth would continue. So moving on, it's stalk rot. We also asked everyone to go out and assess stalk rot at R6 and to assess 6 plants per plot, so 3 plants in rows 5 and 12. And what the pictures I have here are of our, we had a master's student in our lab, Sarah, and we miss her greatly. And she did a lot of work with cover crops, and she moved on to a different lab, unfortunately. But she's showing here how to do the stalk rot assessment, where you split the stalk from the ear, the primary ear, to the soil level, And then you open up the stalk to see the nodes and internodes. And so stock rot percentage is you're counting the total number of nodes and internodes from the primary ear to the ground. And then you're also counting the number of rotted or discolored nodes and internodes. And so therefore then we get a percentage of stock rot from that. Okay, so for overall stock rot across all the locations, it did vary quite a bit, with one state not having stock rot at all, and then other states, having up to almost 40%. Something kind of interesting is that for the green treatment, or when termination occurred after planting, the majority of the states, the greatest was, not quite 16%. So that you can see here, for the first 8 states, that it was quite variable across the states for stock rot, where some states, okay, for example, Iowa there was the most stock rot in the late termination. So that would be the planting green brown. And so termination occurred 3 to 7 days before planting. Whereas other states, Kansas, Kentucky, no significant difference. Nebraska, you have the early, which is planting brown, which is 2 to 4 weeks before planting, where you have the most stock rot. So it was quite variable across that. Although the theme kind of was that the after planting treatment had the lowest amount of stock rot for many states. For the other 7 states, then there again, it was quite variable. It's not that Texas didn't turn in their data, they did not have any stock rot. So Wisconsin, no significant difference, but then we have something interesting in North Carolina, where the stock rot was close to 35% in both the no rye and the after planting treatments, whereas for the early or the brown treatment, it was less. And one thing for North Carolina, and the reason I bring this up is because there's different variables that are occurring in each state, and those things we have to tweeze out to see what could be causing these individual things from happening, such as in Ohio, we have under 5%. We don't have stock rot in Texas, but in North Carolina, they had an insect problem. And so that affected yields, which you'll see on the next couple slides later, that they had very low yields. So, there could be something going on there. So those are the things that we're looking at in the future to see what different parameters might be affecting a lot of these, whether it's seedling disease or stock rot or yield. So to kind of summarize, stock rot is there was more stock rot in the no cover crop, the brown and the green brown treatments, and less stock rot in the green treatments. So not too interesting, but yet, we'll have to dig into it further. And hopefully, one thing I forgot to mention is that this is data from 2021. And so for this year, from 2022 and 2023, hopefully we can get a sense of, what's going on, if there's any shifts in what we're seeing for seedling disease and for stock rot. So for yields across all locations, again, it was variable for the 3 treatments, the brown, the green brown, and the green, anywhere from, higher 60s bushels per acre to all the way up to 250 or more. So yes, very, very interesting, very variable is the theme here. So for yield, there were states, I'm going to pick on Iowa again, that had less yield for the after planting termination treatment. And that was similar to Kansas and other states that I'll see on the next slide. But then we have states such as Florida, no significant difference. Illinois, the most yield was for no rye treatment. And then the others, the lowest yield was in the late and after planting termination treatments. Whereas Maryland had very higher, or I think the highest yields, and no difference between treatments. For these other states, again, variable, where we're either seeing no difference across treatments, or we're seeing, something that certain treatments are lower and other treatments are higher. So, and then here's what happened in North Carolina, that we had very low yields due to an insect issue. So, and higher yields in Wisconsin too. So they're close to 250 also. So to summarize for yield, there's lower yields in the green compared to the brown in 6 of the 13 locations. But then there was more or higher yield in the green compared to the brown in 2 of the locations, which was somewhat interesting. And then there was no difference between yield for green and brown treatments in 5 of the 13 locations. So overall, we are seeing that the rye termination timing did affect seedling disease for the green treatment at several locations. And that was interesting to see, that it wasn't just in Iowa, that there are other states that were seeing this trend. However, there was less stalk rot observed in the green treatments in the majority of states. So that's something, like I mentioned before, about looking at to see, what's going on there, if there's something that we can explain of why that's occurring. Also, there was lower yield in the green compared to brown, whereas many locations showed no difference between the green and brown treatments, or even had higher yield in the green treatment. So a lot of questions, to look at. And what we're trying to then do is look at relationships about seedling disease and yield, or seedling disease and cover crop biomass, and put those things together to see what are all these parameters and how they impact a seedling disease and stalk rot and yield. So other parameters that we did look at were stand emergence for corn, the seedling shoot height and seedling shoot and root dry weights and barren ears, and also different weather parameters, moisture and or precipitation and air temperature and those types of things, to pull that data and see for each location. And then if we can, see some trends that are across different regions within the 16 states that are participating in the project. So that's what I have. If anyone has any questions or comments, or if going through my presentation, you thought of different relationships that we could look at, I'd be very happy to hear them. One thing I did forget to put on the slide is my email. And so if anybody has any questions or comments or ideas later and they would like to email me, it's my first name, Rashelle, at iastate.edu. So thank you.